develop? How our bones develop? What about the mode of bone formation? What kinds of this process know you? What are the types of the process of the bone formation, ossification? No. Ashwin? No? Help us. Yes. Bony tissue and bones, the organs containing this tissue, develop from mesenchyme. You are right. But there are different modes of bone formation. Flat bones, for example, mandibular, bones of the skull, develop from mesenchyme directly. Mesenchyme gives rise to bony cells produce matrix, bony tissue appears, and this bony tissue forms the bone organ. But some bones, tubular bones, development of this bone differs. We name this mode is indirect. Direct from mesenchyme or intramembranous ossification sometimes we name, or there are indirect mode of bone formation. Why indirect, you will understand. Firstly, direct. How? Bony tissue and bones appear. There are mesenchyme. For example, in the limbs develop in embryo. And inferior mesenchyme present. Mesenchyme is a network of cells stellated with processes. These cells contact to form a reticular-like system. It's mesenchymal cells, not differentiated. From mesenchymal cells, different tissues develop. Blood, lymph, loose connective, dense connective, cartilage, bony, smooth muscle, many. I don't understand why, in some cases, mesenchymal cells differentiate into chondroblast, for example, gives rise to cartilage, but in some cases, mesenchyme gives rise to the bony tissue, to bones. What are the conditions that influence on the differentiation? What conditions may influence on the mode of differentiation? Do you know? Vascularization. Appearance or absence of blood vessels in the region where mesenchymal cells differentiate into different tissues. In presence of blood vessels, so level of oxygen is high. In this case, mesenchymal cells differentiate into osteoblasts. If oxygen level is lower, mesenchymal cell prefer to differentiate into chondroblast. So, level of oxygen influence on the mode of differentiation. So, blood vessels appear in the region of mesenchyme, and mesenchymal cells give rise to osteoblasts. Osteoblasts are the cells producing matrix, proteins, lichens. So that's why cells are basophilic. Richness in RNA, rough endoplasmic reticulum, these basophilic osteoblasts begin to synthesize proteins, components of matrix. First amount of matrix is shown here. Then this matrix will surround each cell. Volume of matrix will increase, and bony trabeculae will appear. And the cells that are localized, are surrounded by this matrix will be osteocyte, because activity diminishes. More active during destruction of matrix. When as this cell is surrounded by matrix, activity diminished and osteoblast became osteocyte. Bony trabeculum. Then bony trabeculum will fuse and bone will be formed. New generations of osteoblasts appear from mesenchymal cell, new bony matrix, so a positional growth as in cartilage. Previously, osteoid appears, it's inorganic matrix without salts. Then mineralization is realized and matrix became mineralized. Non-mineralized, only organic, and then mineralized. That's why coloration differs. More denser, more intensive, less intensive. The first tissue that appears in embryo during embryonic development, this trabeculae consists firstly from costly bundle bony tissue. But from blood vessels, monocytes migrate and osteoclasts differentiate from these monocytes. Osteoclasts are bony macrophages, voluminous oxyphilic cells with numerous nuclei. These cells are multinucleated, large, big. We can recognize these cells just at low magnification, are visible compared to osteoblasts that are small. And these osteoclasts destroy this matrix. Compare the animation that we observe. And in this cavity that will appear after digestion of matrix, osteoblasts penetrate there and begin to form new lamellae. And the first osteons will appear. So lamellar bony tissue will replace this costly bundle. Is that clear? So it's the direct mode of bone formation, or intramembranous ossification, directly from mesenchyme. You see frontal section of mandibula. Epithelium covers the mucosa of mandibula. And the mesenchyme, developing epithelium and mesenchyme. And you see pink tinted bony trabeculum. It's bony tissue that is produced by mesenchymal cells. Numerous blood vessels. Peripherally, osteoblast, inside osteocyte and osteoclast. At low magnification, I recognize this osteoclast. To prove my diagnosis, I'll zoom in. And you will see better all cells. Now look, bony trabecula. You see the cells enclosed in this matrix. It's osteocytes. The cells localized peripherally on the trabecula originated from mesenchymal osteoblast, basophilic by the way. Blood vessel, and what is this? Oxyphilic, large, with numerous nuclei. Look, nuclei are numerous here. Osteoclast, and here osteoclast, osteocytes, and osteoblasts. So here, osteoblasts absent. it means the trabecula will grow from this side. Not from this side, but opposite side. It's direct mode of ossification. Directly from mesenchyme. Clear? And the next mode of ossification, indirect. Indirect. What does that mean? Indirect. Who can explain? In what way bony tissue and bone develop? Huh? No. Student, you read textbook. You said me that you read textbook. You had know the questions before the class, so I hope that you understood, huh? What? Endochondral. What endochondral? What are the stages, steps, stages of indirect bone formation? Let's choose white. Mesenchyme. Mesenchyme, 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 mesenchyme. Here. Blood vessel cells. For the moment. Blood vessels will grow later. In this case, mesenchymal cells presented in developing arm, yeah, will produce chondroblasts, and chondroblasts form the cartilaginous tissue, and this cartilaginous tissue forms the model of future bone. So initially, firstly, it's correct? Model of bone. But this so-called bone consists of the cartilage, not bony tissue. Is that clear? So, firstly, during embryonic development, bones of our skeleton, long bones, consist of the cartilage. So we have skeleton partially cartilaginous skeleton, not bony skeleton, cartilaginous. And then this cartilage must be replaced by bony tissue. It's recapitulation of the phylogenetic. Recapitulation means repeat. The embryonic development of skeleton repeats the phylogenetic. Our ancestor. What skeleton was previously in ancestral forms? Highly cartilaginous. Fishes. Today there are fishes with cartilaginous skeleton. Sharks. So, firstly, skeleton was cartilaginous. When these ancestors leave the sea and migrate to the earth, the weight, gravity, cartilaginous skeleton was not optimal. And cartilage was replaced step by step by bony tissue. The same we observe during embryonic development. Embryogenesis repeats phylogenetic evolution process. Is that clear? So, firstly, cartilaginous bone. Bone from cartilage. Hyaline cartilage. Later, blood vessels appear in this region of mesenchyme. Oxygenation arises, so mesenchymal cell differentiates into osteoblasts. These osteoblasts surround diaphysis. Ossification begins in diaphysis and more later in epiphysis. So, and the first bony tissue appears around of diaphysis. first bony trabeculae surround this cartilaginous model, so-called perichondral bone, perichondral bony tissue. Peri means around, perichondral bone. From what cells differentiate this? From mesenchyme. From mesenchyme, as in this case. But compare to this case, initially cartilage and then bony tissue. Bony tissue around cartilage, perichondral bone. And now, tell me please, when bony tissue, solid, impermeable, appears around the cartilage, what about nutrition of cartilage inside? Cartilage is nourished by diffusion. When a bony matrix surrounds cartilage, diffusion is blocked, stopped. And cartilage, without nutrition, begin to degenerate. Cells, chondrocytes die. In absence of chondrocytes, mineralization of matrix, cartilaginous matrix, increase. And who like mineralized matrix? Osteoclasts. Where are our osteoclasts? Who? Blood vessels present in bony tissue. Blood vessels can penetrate, small branches of blood vessels penetrate in the middle part of diaphysis, inferior the cartilage. And monocytes leave blood vessels, differentiate into osteoclasts, osteoclasts destroy cartilage, mineralized cartilage. So, perichondral bone, block of nutrition, cell death, death of chondrocytes, mineralization of matrix, monocytes, osteoclasts, destruction of cartilage. But when blood vessels penetrate mesenchymal cells along with this blood vessel, penetrate to, and osteoblasts may differentiate at the same time. Osteoclast and osteoblast. Do you remember animation? So newborn osteoclasts, newborn osteocytes, osteoblasts begin to produce bony matrix inside of this cartilage. Cartilage is destroyed. Instead of cartilage, bony tissue appears. So bony tissue replaces cartilage. And this bony tissue that appears inside of this model is named as endochondral bone. And we say endochondral ossification inside of the cartilage. Cartilage destroyed, bone appears. Clear? This process takes place in the diaphysis. Later, ossification will appear in epiphysis, but perichondral bone absent in epiphysis. Why? Only endochondral ossification will be realized in epiphysis, and perichondral absent because a plate of cartilage must be presented on the surface of epiphysis, articular cartilage, yeah? And during some decent years, 15, 20 years, plate of cartilage will be presented between diaphysis and epiphysis, metaphyseal cartilage. And you remember that hyaline cartilage, any cartilage, interstitial growth. Cartilage, volume of cartilage increases. But from this side and from this side, this cartilage is attacked by osteoclasts and osteoblasts. Cartilage, growth. And here, destruction, replacement by the body. So, length of the bone increase. Exactly. Is metaphyseal cartilage or metaphyseal plate. Now, grow the thickness of bone, diameter, growth in diameter, due to the presence of periosteum containing osteogenic cells. Clear?
Yes.
Now look, you see tubular bone, it's a diaphysis. I move the slide across, diaphysis. One side, another side. On the surface you see periosteum, dense connective tissue. At left, move, having cartilage. For this stage, epiphysis is not ossified yet. Only cartilage present here, ossification absent for the moment. Opposite, the same. Cartilage only. Well, bony trabecula, pink tinted, fuse together to form the compact bone. Yeah? What bone appears firstly? Perichondral. And interior, you see the endochondral ossification. Here, bony trabeculae contains the debris of cartilage. In what way we can recognize, differentiate, we can show the trabeculae of perichondral bone and endochondral. Look, perichondral is pink. Pink. The same structure. Osteocytes, osteoblasts, same process. Perichondral. Now endochondral trabeculae. Look. See your bluish, slightly basophilic masses. See your isogenic groups. It's debris of cartilage that is destroyed and is replaced at the same moment, is replaced by bony matrix, pink. Bony matrix, debris of cartilage. Cartilage disappears, bony matrix appears. So, endochondral ossification. Replacement of cartilage by the bony tissue. Clear? That's all, my dear friends. Unfortunately,